In this video, we'll be looking at the new Masso closed-loop stepper motors with integrated motor drive. By having all the electronics and positional feedback encoder built into one small package, the motors can deliver high torque with position control. And by having an integrated design, the motor setup and wiring become easy. The motors are designed to work with differential control signals which provide high immunity against electrical noise such as VFDs and plasma sources. This means that longer, low current control signal cables can be used between the Masso controller and the motor. Connection is easy. Connect S plus to S plus, S minus to S minus, D plus to D plus, D minus to D minus. There are two more terminals that we need to connect, and the first of these is the enable input. This is labelled EN on the motor. This needs to have a 5 to 24 volt signal applied to enable the motor. Ideally, this will come from the Masso e-stop relay, and it's used to disable the motor whenever the e-stop button is pressed. Removing the voltage will disable the motor. This also gives added safety. If the enable signal cable is disconnected or the cable is damaged, then the motor will enter an alarm state, and it will also signal Masso to stop all motion. The last signal to connect is the alarm output. It's labelled AL on the motor. This connects to any input on Masso, and a 10k ohm pull-up resistor is also connected to the input, and the other end of that resistor connects to one of the red auxiliary power terminals on Masso. I suggest you sleeve the resistor as shown here to protect it from accidentally contacting another circuit. In the Masso F1 screen, configure the input as an axis motor alarm. The one you choose will depend on which axis your motor is connected to. Now we have all our signals connected, it's time to connect our power supply. The motor can run on a 24 to 36 volt power supply, though 36 is the recommended. The motor can draw a maximum of 4 amps, so ensure your power supply and cabling is capable of supplying the necessary current. When connecting power to the motor, please ensure you get the polarity correct, as getting it wrong will damage the motor. It's important that you connect the negative of your motor power supply to the negative of the Masso power supply to form a common ground. Without this connection, the alarm and enable signals will not work. Connect this at the main power distribution point, and please do not use the black ground terminals on Masso for this purpose. The final thing we need to do before powering up our motor is to set the dip switches. It's important to note that the power must be disconnected when making changes to these switches. Dip switches 1 to 4 set the motor resolution. As a general rule of thumb, you want to set this to about 2000 pulses per revolution or lower. Of course, each machine will have different requirements, so choose your settings accordingly. Dip switch 5 must be set in the off position. Dip switch 6 can be used to reverse the direction of your motor. But remember, turn the power off before making changes to any of these switches. Now we have our dip switches and resolution sorted. We can go into the F1 screen, Access Setting page, and enter the stepper resolution we selected on our stepper motor into the drive pulses per revolution and click Save. There will be more to enter into this page later as part of the machine's setup and calibration. I can now pop the cover on the drive and power up the motor. You'll notice that the green power light turns on, indicating that power is applied. There is also a second LED indication on the drive. This is a red alarm indication and will turn on whenever the motor goes into an alarm state. This could be caused by the motor being disabled because Masso is in an e-stop condition. The step signals sent to the motor exceed the motor's maximum speed. The voltage applied to the motor is more or less than the motor specifications. There is insufficient current to power the motor for the load, or the motor is unable to make the required move as requested. This could be caused by mechanical issues on the axis, or the motor may have stalled because you've run into something. If this happens, an alarm is sent to Masso and the program will stop. The advantage of being a closed loop stepper motor is its ability to monitor position. This means it won't easily lose position, and if it does, it will let you know by going into an alarm state. You can see here that if I purposely move the motor from its position, it will move back by itself. The motor can correct itself from an error of up to 1 full revolution. With a normal stepper motor, once you lose a step, it's lost forever. There's no way to get it back. The motors come in NEMA 23 format with 8mm shafts and are available in 2 different torque ratings. There's 2 Newton meters or 270 ounce inch and 3 Newton meters or 425 ounce inch. Both are popular motor sizes used in CNC machines. If you're looking for a stepper motor with built-in differential drive, why not have a look at the Masso closed loop stepper motor? Well, that about wraps it up for this one. If you'd like to see more videos like this, why not consider subscribing and ring that bell for notifications of all new videos as they're released. All that remains for me to do is to thank you guys for watching, and I'll see you next time. Cheers.